Hello, welcome to our show, I guess. We are the UC Claremont College Geology Undergraduate Research Group, and we have taken a spectacular journey. We have taken a drive of 1,263 miles from Batavia to this cabin, which is between Custer, South Dakota and Pringle, South Dakota. We were on the road at least 18 hours, and we did manage to stay last night in a lovely cabin, and now we're here where we will be for the next 18 days. And so we wanted to show you and share with you a bit of our journey. And first of all, I wanted to show you how far we've come on this map. We've come from Batavia, Ohio, clear over here to this domal uplift of the Black Hills of South Dakota. And on the way, we have passed through mostly glacial terrain. The glacial features consist of everything from ground moraine, till, mixed, ground up rocks brought down from the Canadian Shield and gathered locally, and then also, of course, large erratic boulders that are hard and resistant minerals, quartz and so forth. They were brought clear from Canada by these ice sheets that were at least 2 miles thick, and they covered this whole northern extent of our North American continent. And what they left behind is mostly ground moraine, but it's punctuated by lots of different features that tend to make things a bit flattened in terms of the topography and cover the geology that lies beneath. So the structural geology and the basement geology under the glacial drift is obscured in large part. And so what these students rode through for 18 hours approximately was mostly glacial cover and features. And if you pick out the subtleties in the glacial terrain, there are lots of good things to look at. And so we saw drumlin swarms, we saw cames, we saw eskers, we saw glacial outwash where the meltwater had taken sand and gravel that the glacier was carrying and spread it out in a plain, and where there are now sand and gravel resources to be mined. And then also we passed over through the mid-continent in Iowa, Grundy County and so forth, where the glacial terrain had covered up the basement structures, the Precambrian 2 billion years, 3 billion years old structures in the basement where the whole continent had tried to pull apart, just like the African rift systems, just like the Red Sea and so forth, but that failed. So the plate reconnected itself, glued itself back together. But if you look at seismic data from 20, 30,000 feet down, you'll see these huge mountains that were left behind by this tensional pull-apart faulting. And we're not aware of those at the surface because, gosh, they're worn down, first of all, and then they're covered by all these thousands of feet of sediment that were deposited over time. And then lastly, by the glacial cover. And so there aren't really indications of all that on the surface, but if you drill down, you can get samples of the rock, and they contain a variety of minerals that we may need someday. And there are opportunities for oil and gas traps at those depths. And so fascinating geology can be covered by the glacial drift. But then as we progressed westward, we progressed across the sediments of the Great Plains that were shed off the rising mountains in the west. and where the Cenozoic herds of primitive mammals first appeared and then died in ash falls and volcanic activity during the Cenozoic. And we passed over all of that, and then, oh, wow. After going flatland, and then rising Great Plains, abruptly in front of us, mountains, mountain peaks we could see while we were still on the plains. And as we got closer and closer to that uplift of the Black Hills, we saw the sedimentary beds dipping away. And those sedimentary beds had once covered that uplift, been continuous across it, but as the uplift occurred and was exposed by erosion, the oldest rocks in the center were exposed, so you can now walk over them and collect them and mine for the minerals in them. And then all around the edge are the rocks that are younger that were covering those materials as they rose up. And so now you have structural uplift, and you have dip on those beds, which were originally probably fairly flat lying. And so the Black Hills are ringed by an aureole of sedimentary cover. And in the center and toward the center, we have metamorphic rocks. We have phyllites, schists, and gneisses that have garnets and other valuable minerals. And then we have the igneous rocks. In the center, we have Mount Rushmore with the Rushmore granite and so forth. And then shot through this whole complex of sedimentary and metamorphic and igneous rocks, we have hydrothermal veins that carry valuable minerals like gold, and that disseminate those minerals through the rocks in places, so that you have one of the most productive gold mines in history here in the Black Hills. It has now been closed down for neutrino research, but it was very productive. Homestake mine, and the rocks surrounding that. And so what we intend to do on this trip is to study the origin of this uplift and the adjacent sediments, including the sedimentary section in Wyoming adjacent to the Black Hills that contains fossils of dinosaurs that lived during the Mesozoic and became extinct during the Cretaceous. And so we'll see those, and we'll see the sediments that reflect the environmental conditions when those dinosaurs were alive and as they died and after they died. And we'll see in the Black Hills volcanic rocks, igneous rocks, metamorphic rocks, sedimentary rocks that were all involved in this heavily mineralized, commercially important mineral development that we have here in the Black Hills. And we want to test the rocks that we find and the hydrothermal veins that we find to see with the XRF handheld portable niton instrument what elements those are carrying and what valuable minerals we might find. Now the Black Hills are being explored for rare earth elements, and there's a new critical elements list, critical minerals list, that has been published by the USGS in January of this year. And so we want to explore here and see what we can find that has not yet been discovered. And so we have these eager students who are interested in learning about the history of this area in terms of its progress through the last 3 or so billions of years up until present. And so we'll explore that, we'll take samples, and we'll take those back to the lab, and they will write and publish papers based on their analyses of the data that they collect here in the field. And so this is important experience in their academic careers, both in terms of their ability to employ the scientific method and study the rocks of the earth and how they came to be, and how mankind can best use these in an environmentally sensitive manner, because we know how to do that now. It's also to learn of the history of the development of our country, of the native peoples who were here and considered the Black Hills magical and spirit-filled and sacred. And we also appreciate that aspect of the Black Hills. The air is clean and fresh and cool, and it envelops you in this wonderful, uplifting joy to be here as a part of this and to learn more about it. The animals that live here, the people who live here, and the history of the people who developed this area. And with that, we have cultural aspects, biological aspects, geochemical aspects, geological aspects, structural aspects. We'll do mapping in the field. And these students will have an experience of being here and appreciating the scale of geology and the scale of movements on Earth and the scale of the gifts we have from the Earth as well. And they will learn how to collect data and label it and keep track of it properly and how to analyze it, and then how to see how that all fits together to form a story, to form a picture, to reflect the data, to learn more about the area, to contribute to science, to contribute to the body of literature, and they will publish that and disseminate their knowledge. And that gives them valuable experience, not only in having been in this place and had the physical, hands-on, visual, auditory, sensory experience, but also to have the experience, the academic experience of writing it up after they analyze it and present it to people who have questions and perhaps are a bit critical of what their conclusions might be and what they see in their results and what their experience has been. Interact with different people from the scientific world. And so we plan to go to GSA in November in Indianapolis and present this work. This great group of students has already presented at the Ohio Academy of Sciences in April, and they did a great job, fine job. And they are bright, and they are eager, and they are learning, and they are expanding their universe. And they are expanding the universe for others as well, the people that they'll touch throughout their lifetimes, not just as an undergraduate, not just getting a bachelor's degree or a master's or PhD, but throughout their lifetime. And this is how we grow this information, this understanding, along with the wisdom of place, the value of place, the wisdom of the spirit of that place, and the joy of that place, and sharing that with others. And so I hope you'll continue to go with us as we continue on our journey. And we're happy to be with you, and we are grateful to our Office of Research at UC. We're grateful to our Dean Bauer. We're grateful to our Department Chair, Ian Clough, and to our Associate Dean, Mona Cedric. And we appreciate your support so much, and we hope you'll stick with us and ask us questions. And we hope that you'll want to share this adventure, maybe even come out yourself with us at some point. So, welcome, and take care. We'll be with you in a bit. Thank you.